As the 2025-2026 winter approaches, anticipation and concern are building among scientists and the public alike. This season, the stakes are higher than usual, with experts warning of a potentially historic atmospheric event that could reshape the winter ahead. Meteorologists are on high alert for a major atmospheric disruption, closely monitoring every shift in the upper atmosphere. Their models and forecasts are picking up signals that suggest something unusual is brewing, something that could have far-reaching consequences for millions. High in the stratosphere, a sudden stratospheric warming, or SSW, looks increasingly likely for late November or early December. This rare phenomenon involves a rapid temperature spike in the upper layers of the atmosphere, disrupting established weather patterns far below. When an SSW occurs, it can shatter the stability of the polar vortex, a swirling mass of cold air that usually remains locked over the Arctic. If the vortex weakens or splits, it can unleash weeks or even months of cold, volatile weather across the northern hemisphere, sending frigid air plunging into regions unaccustomed to such extremes. An early SSW is rare, and can lock in a cold pattern for the entire winter, raising the risk of severe cold snaps and major snowstorms. Cities that typically see mild winters could face relentless snow and ice, while regions already prone to harsh weather may experience even more intense conditions. This forecast hinges on three key factors: the quasi-biennial oscillation, a weak La Niña, and their complex interactions with global weather systems. These elements are aligning in a way that could amplify the effects of any stratospheric disturbance. Another crucial ingredient is low Arctic sea ice. As the ice retreats to record lows, it alters the balance of heat and moisture in the atmosphere, making it easier for cold air to escape the polar regions and surge southward. We'll explore how these powerful forces are converging, setting the stage for a winter unlike any in recent memory. The interplay between ocean, atmosphere, and ice could create a perfect storm of conditions for extreme weather. The story begins miles above our heads, where a stratospheric disturbance could soon send shockwaves through our daily lives, reminding us just how interconnected our planet's systems truly are. Most official winter forecasts, like those from NOAA or ECMWF, are built on slow-moving climate drivers. This year, a weak La Niña. These agencies rely on decades of climate data and sophisticated models to predict what the coming months might bring. Their outlooks are trusted by millions, from city planners to everyday people deciding how to prepare for winter. But even the best models have their blind spots. Historically, La Niña points to a mild winter for much of the US and Europe. This means warmer temperatures, less snow, and fewer disruptions. At least that's what the statistics suggest. People often look forward to these milder conditions, making plans based on the expectation of a gentle season. But these models often miss sudden, high-impact events like an SSW, which can override all other signals. Sudden stratospheric warming is a rare but powerful phenomenon that can flip the script in a matter of days, catching even seasoned meteorologists by surprise. Once an SSW hits, it becomes the dominant force, rendering La Niña-based predictions obsolete. The stratosphere can unleash a cascade of changes, sending cold air plunging south and triggering storms where calm was expected. This winter, the stratosphere is poised to take control, flipping the expected mild pattern to one of cold and storminess. The shift can be dramatic. One week, people are enjoying unseasonably warm days, and the next, they're facing blizzards and icy winds. The public and planners may be caught off guard if they rely solely on static seasonal outlooks. Businesses, schools, and emergency services could find themselves scrambling to adapt to rapidly changing conditions. The lesson: climate averages can be upended by dynamic short-term events. Weather is not just about long-term trends, it's also about the unexpected twists that can happen at any moment. This season could be a case study in how a single atmospheric shock can rewrite the winter script, reminding us that nature always has the final say, and that flexibility and awareness are key to staying prepared. A sudden stratospheric warming, or SSW, is one of the most dramatic and fascinating events that can occur in our planet's upper atmosphere, especially above the polar regions. It's a phenomenon where, in a matter of just a few days, temperatures in the stratosphere, an atmospheric layer sitting 10 to 50 kilometers above the surface, can suddenly spike by as much as 50 degrees Celsius. This rapid warming is not only rare, but it also has far-reaching consequences for weather patterns across the northern hemisphere. When an SSW occurs, the polar vortex, a powerful band of winds that usually circles the Arctic and keeps cold air locked in, can be dramatically disrupted. The winds that typically flow from west to east may even reverse direction, causing the vortex to weaken or split apart. This breakdown in the polar vortex is a key reason why SSWs can have such a profound impact on our weather. But what actually triggers this sudden warming? The answer lies in planetary waves, giant ripples in the atmosphere that are often generated by the interaction of air with mountain ranges, or the sharp boundaries between oceans and continents. These waves travel upward from the lower atmosphere, and when they reach the stratosphere, they can break, much like ocean waves crashing on a beach. This process releases energy, rapidly heating the stratosphere and setting the stage for an SSW. The chaos unleashed in the stratosphere doesn't stay there. It quickly descends, disturbing the jet stream, a fast-moving river of air that usually flows in a relatively straight path from west to east. After an SSW, the jet stream can become much more wavy and erratic, dipping far to the south in some places and surging northward in others. This new meandering pattern is what allows cold Arctic air to escape its usual confines. As a result, frigid Arctic air can plunge deep into North America and Europe, bringing with it severe cold snaps, heavy snowfall, and even prolonged winter storms. At the same time, blocking patterns in the atmosphere can cause weather systems to stall, leading to extended periods of extreme weather, whether that's bitter cold, snow, or even unusual warmth in some regions. In many ways, SSWs act as a master switch for winter weather, flipping the northern hemisphere from a period of relative calm to one of chaos and unpredictability. The effects can be felt for weeks, sometimes even months, after the initial warming event. After an SSW, you can expect persistent cold, frequent snowfalls, and a general sense of unpredictability in the weather. Cities and rural areas alike may experience snowstorms that linger for days or even weeks, making winter feel longer and more intense than usual. The newly contorted jet stream can bring frigid outbreaks to some regions, while others might see unusual warmth or powerful storms. This means that while one area is buried under snow, another might be experiencing rain or even a midwinter thaw, all thanks to the same atmospheric event. Understanding sudden stratospheric warmings is crucial for meteorologists and anyone interested in weather, because these events can explain why a winter turns out to be so extreme, unpredictable, and memorable. The first pillar of this forecast is the quasi-biennial oscillation, or QBO, a regular shift in stratospheric winds above the equator. The QBO alternates between westerly and easterly phases every 28 months. This winter, the QBO is in its easterly phase, making the polar vortex weaker and more vulnerable to disruption. An easterly QBO acts like a wobbling top, easily knocked off balance by planetary waves. This phase allows more energy to reach the vortex, increasing the odds of a major SSW. Forecasters watch the QBO closely. Its current state is a flashing warning sign. With the vortex primed for disruption, only a modest push is needed to trigger chaos. The QBO's influence is the first key ingredient in this unfolding winter drama. The second pillar is a weak La Niña. Not as a source of mild weather but as a catalyst for stratospheric disruption, La Niña alters tropical rainfall, fueling planetary waves that can destabilize the polar vortex. This year's configuration is perfect for generating the kind of wave energy that triggers SSWs. Instead of bringing warmth, La Niña is helping to build the battering ram that could break the vortex. When La Niña's wave engine runs alongside an easterly QBO, the result is a recipe for cold, not mild, winter. The interplay between Pacific conditions and stratospheric winds is amplifying the risk of a dramatic pattern shift. La Niña is a key player, but for reasons most forecasts overlook. The third pillar is record-low Arctic sea ice, especially in the Barents and Kara seas. Open water releases heat and moisture, fueling high-pressure blocks that disrupt atmospheric flow. This blocking weakens the jet stream, making it wavier and more likely to send energy upward to the stratosphere. Low sea ice amplifies the very planetary waves that can shatter the polar vortex. Combined with the QBO and La Niña, the Arctic's missing ice is the final piece in a perfect storm. Each factor alone raises the risk of disruption. Together, they make a major SSW highly probable. The Arctic state is no longer a distant climate metric, it's an immediate driver of our winter weather. The stage is set for a top-down transformation of the season. Once the SSW hits, North America will feel the effects quickly. Expect a negative Arctic oscillation and North Atlantic oscillation, patterns that open the floodgates for Arctic air to surge south. The central and eastern US and much of Canada face a high risk of prolonged, severe, cold, and major snowstorms. The jet stream will become wavy, allowing deep troughs to funnel frigid air far south. This isn't just a cold snap, it could mean weeks of below-average temperatures and high energy demand. The setup resembles the historic December 1989 cold wave, not a typical La Niña winter. The West Coast may see milder, drier conditions as the cold focuses east. The bottom line, a dramatic top-down pattern flip that could define the winter for millions. Europe too will see a dramatic shift as the SSW triggers a negative North Atlantic oscillation. A Greenland block will reroute the jet stream, shutting down mild Atlantic air for northern Europe. The result, persistent cold, dry spells for the UK, Scandinavia and Germany, echoing the beast from the east of 2018. Meanwhile, southern Europe will be in the path of an active storm track, facing heavy rain, mountain snow, and flood risks. The SSW splits Europe in two: cold and blocked in the north, stormy in the south. This pattern overrides the usual weak La Niña signal, making the stratospheric disruption the dominant force. The Greenland block will dictate Europe's winter, from temperature to precipitation. The looming SSW is a wake-up call for modern forecasting. It shows why we must move beyond static climate-based models and embrace dynamic, event-driven prediction. SSWs are rare but powerful, and current models still struggle to anticipate their full impact. The best forecasters synthesize signals from the QBO, Arctic ice, and planetary waves to spot these game-changing events. This winter's forecast is more than a prediction. It's a call to adapt our expectations and methods. The future of forecasting will blend climate models with real-time event analysis to catch these atmospheric wildcards. The 2025-2026 winter may be remembered as the season that redefined how we understand and predict extreme weather.